Hello everyone, welcome to John Math Classroom. In this lesson, we are going to discuss about the Argan plane. It's easy to plot a real number on a real number line. For instance, the number 3 can be plotted here. The number -4 can be plotted here. What if we have the order pair of number, something like the coordinate where we have 3, 2? How can we represent the 3, 2 on the xy plane? How can we represent the coordinate 3, 2 on the xy plane? 3 units to the right on the x-axis where we have the situation, and 2 units up on the y-axis where we have the situation. So give us the point with the coordinate where we have 3, 2. Given a name where we have the P. Now look at the complex number where we have 3 plus 4i. The number has a real part and imaginary part. What if we want to plot 3 plus 4i on the plane? How can we do that? A good idea would be assume that the x-axis as a real axis and the y-axis as an imaginary axis. Based on this, we can say that the complex number 3 plus 4i correspondent to the order pair where we have 3, 4. 3 is the real part and 4 is the imaginary part. Remember that the horizontal axis is the real axis and the vertical axis is the imaginary axis. So 3 units right on the real axis and 4 unit ups on the imaginary axis. This will give us a position of the complex number on this plane, where we have 3, 4. Name it as P. Do you remember what the plane was called? This is called a Cartesian plane. How about the right hand side? It is called the Argan plane. A complex number, z is equals to a plus bi, is simply written as bracket a, b. And this can be represented on the Argan plane. Since that the point is here, where we have on the x-axis, this number will only have the real part and it can be written as the coordinate 5, 0. Or in the complex number, we will have z is equals to 5 plus 0i. If the point is here on the x-axis, it will be with the coordinate -3, 0, or we can express in the complex form where we have z is equals to -3 plus 0i. What is the point in here on the y-axis? Every point on the y-axis will only have the imaginary part. So for this point, we will have the coordinate 0, 3. Or we can express z is equals to 0 plus 3i. Every point on the x-axis corresponds to the complex number of the form z is equals to a, where we have the real part, plus the 0i. And every point on the y-axis corresponds to the complex number of the form z is equals to 0 plus bi. So now, you have learned how to plot or represent a complex number z is equals to a plus bi on the Argan plane. Let's assume that a and b both are positive. We will move a unit to the right on the real axis and b unit up to the imaginary axis. And finally, we will have the coordinate where we have P bracket a, b, which is the coordinate for the situation. Let's the origin O, where we have the location 0, 0. Now just focus on the point P. If you want to ask your friend to plot the point P, how would you do it? Your friend just have an empty graph and you wish to ask your friends to plot the point P. Let's move on to another graph. So one thing you could tell your friend, A units to the right and B units upward, and you will get a point P. Is there any other ways in which you can ask your friends to plot this point? Let me give you a hint. So I join the point O to P, and I will call it an angle, which is the alpha, or we can say the basic angle, and assume this as the length, which called R. What can you tell your friend such that he or she plot the point P correctly? Well, you can tell your friend two things. First, the distance of the point P from the origin, and the second, the angle at which the length OP is placed from the positive side of the horizontal axis. This was another way to represent the point P. Your friend, either with the unit A and B, or the situation we have the length R and the angle alpha. So your friend will be able to plot the point P. This is what we call the polar representation. Now we are going to represent the complex number Z is equals to A plus BI from the Cartesian form to the polar form. A complex number Z is equals to A plus BI can be plotted in two ways. First, A unit to the right on the real axis, and B unit up on the imaginary axis. Assume that the length OP is R, and this angle from the positive x-axis is alpha, or we may represent it as a theta. So it depends on the situation, and we denoted the situation as the basic angle. The second way to represent the point P is where we have A, B, or we can say it R, either alpha or theta, which is the basic angle. If you're looking at this right angle triangle, this length is the A for the x-axis, and this length is the B for the y-axis. This length is R. The angle of the POA is the alpha, or we may represent it as a theta. And this angle is 90 degrees. So now, let's just focus on this triangle. Let me ask you a question. Can you tell me the length of R in terms of A and B? I think you should be able to answer these questions, as this is a right angle triangle, and we can use the Pythagoras theorem to find the R, where we have R squared is equals to A squared plus with the B squared. So in order to find the R, so we can square root both sides. Then we will have the situation which is the R is equals to square root of A squared plus with the B squared. So for the situation, we can say the absolute value of the complex number Z is equals to the square root of A squared plus with the B squared, or we can say it as R. So for this situation, we have the angle. So what is the angle? Or we can say what is the alpha, or what is the theta? So it is called the argument of Z. So in here, we let the theta for the situation, which is equals to the argument of Z. So before this, we have represented the R in terms of A and B. So now we are going to represent the theta in terms of A and B. We can use the trigo identity in this triangle. Do you have any idea? So here we have the trigo identity in the triangle, which is the sine is equals to opposite over hypotenuse. The cos is equals to adjacent over hypotenuse. And the tangent is equals to the opposite over adjacent. So in here, sine theta is equals to opposite over hypotenuse. So in here, the opposite, which is B, the hypotenuse, which is equals to R. So we have sine theta is equals to B over R. And we can get the value B as B is equals to R multiplied with the sine theta. Next, we have cos theta. So as we all know, cos theta is equals to adjacent over hypotenuse. So in here, the adjacent is A and the hypotenuse is R. So and we can get A is equals to R multiplied with the cos theta. But we still don't have the theta in terms of A and B. Are these two enough to give us that? The answer is yes. All we need to do is to divide B by the A, where we have R sine theta over R cos theta. If we simplify the situation, and we will have B over A is equals to sine over cos, and we will have the tangent theta. So from here, we are going to express the theta in terms of A and B. So as a conclusion, theta is equals to the arctangent bracket where we have B over A. So finally, we have already expressed the theta in terms of A and B. With the Argan plane, we have successfully represented the R and the theta, where we have R is equals to the square root of A squared plus B squared in order to find the length. Next, in order to find the angle, we have arctangent bracket B over A. So now we have the real and the imaginary part of the complex number. So now we are going to represent the polar form as well. In the process of doing this, we have also derived a couple of other relations. For example, where we have A is equals to R cos theta and B is equals to R sin theta. So the complex number Z, we have A plus BI is equals to, where we have the A which is equals to R cos theta plus with the R sin theta multiplied with the I. Notice that we have the common factor for both terms, which is the R. So kindly factorize the situation and we will have A plus BI equals to R multiplied with the cos theta plus the I sin theta. This is the polar form of the complex number. So R is the modulus of Z, where we have R is equals to the square root of A squared plus B squared. And the theta is the argument of Z, where we have the arctangent bracket B over A. If we are given the coordinate A and B, then we can get the R and the theta. If we are given the R and the theta, we can get the value for the real part A and the imaginary part B. Why we need the polar form? We all use this concept in locating a point. We specify direction along with the distance from the center point. For instance, while marking place on the map, we said that the particular city is 200 km northeast. So R is equals to 200 and the theta will be equals to 45 degrees. This is one of the usage for polar form. So next we are going to discuss the example for the Cartesian form to the polar form. So here we are, and thanks for watching.